Hey guys, yeah, today we will learn about the impedance. The previous lecture, I little bit explained about impedance, right? Um, let's see, okay? So we use it impedance in the AC, you know what I mean? So what does that mean, impedance first? Uh, it gotta be almost same meaning, prevent current. But in the DC, we use only say resistance, right? Resistor. But in the AC, we say impedance. Let's see what's the differences between them, okay? So let's move on to the this, guys. Yeah, here. So look at the guys here. So here, you can see here triangle, reactance, and resistance. First of all, you need to know about this meaning. Resistor means we already know. It's prevent the current, right? But what is the reactance meaning? So, for example, okay, I will give you this pawn. I will say this is money, okay, to this bar. So, if I use it, the money or lost it, it's gone, right? So there's nothing left. We say this is, actual use, active power or active loss, right? For example, reactive power, we say, I give you, and you store it, okay? You just save it and return back. So actually, there's no loss and there's no usage, right? So we say this is reactive power. Got it, right? So let's see more. So here, guys, imaginary number is J minus J here, real number. You guys can see, right? So if you guys remember the pure, resistor, we say jet is jet 0, right? And in the inductor, we say jet is it doesn't work. Minus here, inductor. And capacitor, we say jet minus 9 here, minus J. So if you guys did understand what I'm saying now, try to see the previous lecture, okay? And so what I want to say is, so impedance, we use it to this, look at that. Impedance is R plus JX. So JX, you know what I mean? Reactance. There's two reactances. So one is omega L and one is omega C. This is capacitor's reactance and this is inductance reactance. So let's see more. So, nice. So first of all, we need to know about the reactors. Yeah, reactors, we need to remember this. Look at the equation. V equal dt, dt, and ti, t. So, which means time goes by, I is changing, the V is, induced. So what I mean is in the DC, there's a current is, no changing. So that's why we say in DC, the coil is, we say it's short, right? And in the AC, it's changing. That's why it's having a meaning. So we say this is, the voltage is induced. But as you guys can see here, look at that. this is coil. If the flux is coming here, because of inertia, they make it the other way, right? This pi. Okay. So because of inertia, look at that. If it's the current is here, right? But because of inertia, so it make it this way. So it prevented the current. So we say this is a reactance because of inertia. If you guys didn't understand what I'm saying now, try to go to the previous lecture and have to watch the Lenz's law. Okay. And also saying, what is that? Here also C, capacitor, you know. You guys can see like a battery, right? So capacitor equation is this. I equal dt dv t. So time goes by, if voltage is changing, the current is coming through. So capacitor's priority is infinite, open circuit, because it's dielectric, right? So if you watch these lectures, I mean the previous lectures, and we understand the knowledges, and now you guys could easily understand what I'm saying. We don't need to memorize, right? So in the DC circuit, there's no voltages changing, right? So we say this is open. In the DC circuit, capacitor is open circuit. And in the AC, it has a meaning. So that's why it could make it could follow the current. But this is a different current. This is a displacement current, right? Yeah. So because of priority, this is an open circuit. That's why it prevents the current, right? So that's why I'm saying this is a reactance. But impedance is, I said, including R plus JX, reactance. Reactance is gonna be inductor part and capacitor part. And resistor is actual loss, right? But as I said, this part, reactive part, is, not actual use. Okay, let's move on. Where is it? Give us a guys. Okay, this is you can see power dissipation in pure inductive source, or this is AC circuits in the capacitor. So what I want to say is, look at that. Let's move on. I'll explain more about it. So what I want to say is, guys, here. So we say this is very it's an instantaneous value I and T and T. Yeah, and if we do inertia, so this gotta be this is instantaneous value, right? And if we do make it to average value, so which means plus here and plus here plus here plus here part, the sum of the value is gonna be 0. So I said you don't need to remember this equation thing, okay? Just try to understand. I gave you store it everything, and you return it back, right? So look at that. Here is we say plus. Here is we say minus. For example, understanding easy. So generator, for example, generator G. I will say generator, and this minus is a load. I will say. So plus part, generator is giving to them. We say supply, and load is using the energy, right? So we say this is use. Sorry, this is supply. supply S. And also we could do it to this here, this part. Load also could give them. It could be supply part and give it to this generator. It gotta be usage. So it gotta be to this, right? So L and C, I said reactance is right. So L is, is saved to the magnetic field energy in the coil, right? And this is saved like a battery. We say like a charge, right? We are charging the charge, right? It's sounds like a weird. But what I mean is, in the battery, we charge, right? The electrons. Yeah. So it saves the charge energy capacitor, right? So look at that here, guys. So I was saying here, L is omega L, and 2 pi f L. This is from the 0 ohms. I said in the DC, there's no, it's gotta be short. But instead C, look at it here. It's infinite, open circuit, right? Open. So which means look at that. C is omega C 1 and 2 pi f C 1. So we need to see here the frequency. It's a proportional. If it's the L is, XL is, if the frequency is up, XL is up, right? But instead, if the frequency is up, so C is down. What does that mean? If C is down, what does that mean? What I mean is XC is down. What does that mean? Reactance is down, right? So I said reactance is kind of prevent current, right? So if the frequency is up, so the reactance is gonna be down, XC part. So it gotta be more current is, easily, control. That's the differences. So we need to learn about this natural property. And now someday, some point, they will meet this point naturally. So we say this is a resonance frequency. We say this part. But it started from infinity, C, and L is started from 0 ohms. Yeah. And lastly, I will explain one more time. L, we have to remember, okay? V, T, dt, d, I, t. Time goes by. If I is changing, the voltage is induced. C is I, t, dt, d, v, t. Time goes by. If a voltage is changing, current is coming through. That's it, today's lecture. Thank you, guys.